Hello everyone, my name is Shahbazi and I'm teaching advanced function in this like a live stream, and we had a couple of sessions until now. We worked on a polynomial functions and we are gonna continue to the rest. I'm a math teacher for so many years and I'm teaching math in high school level and university level. Here I'm just working on advanced function, and as I told you, we just finished the polynomial. We catch up some of the polynomial function. You can see my previous like a live stream to catch up whatever that you missed until now. Last class we worked on a sketching polynomial function for factored form with different order on their roots, and today we are gonna continue for the next lesson the transformation and also practice a little bit more about whatever that we learned last class. uh, I'm gonna start the lesson. Before starting the lesson, I would like just to let you know that the OneClass company is offering 100,000 hours of a free one-by-one tutoring services online that you can sign up for it. The link and the address is on a website. You can find it out and you can apply. It's a good opportunity to use. Here I'm gonna start the lesson. It is our lesson from the last class. We did two questions, another two questions left for you to do it, and if you have any question you can ask here, but I want just to do it for a warm-up. As you remember, we said that when we want to sketch a polynomial functions, we have to write it down in a factored form. Here is not in a factored form. I'm gonna write it down in a factored form. Oops, it's not a factored form still. Is a x minus 1 and x plus 1. The degree of this function is 3 odd degrees. They are opposite in they are following each other in opposite directions. Sign of leading coefficient is negative. Because sign of leading coefficient is negative, at the right side is gonna end up at the down. Then because they are following opposite directions, gonna be a start from there, then q2 to q4. X-intercept, as you can see on the top, it's gonna be 0, 1, negative 1, and y-intercept is gonna, because I have x-intercept 0, right away I'm gonna write it down, y-intercept is 0. All of the roots are order 1, then there is no bouncing point, there is no curving or inflection point. The only things that I need to do is to connect this point. For the next question, here degree of one of them is x, the other one x4 3, then it's gonna make me 1 x4. Degree is gonna be 4, leading coefficient is positive. Okay, let's see for quadrant. Degree is 4, both hands are following same direction. Leading coefficient is positive, means that right hand side is gonna be to the positive infinity or on the top, but because they are following the same direction, it's starting from there too. Then as you see how easily you can write it down the end behavior if you just know one rule, that positive leading coefficient is finishing at the positive right side, top side, and the odd degrees are following opposite direction, even degree same direction. Okay, x-intercept is a 0 and 3 is in order 3, and y-intercept, because I have a 0 here, right away is gonna be 0. I have a two roots here. One of them is a inflection point or roots with the curving. The other one is a order 1. I'm just passing with curving, and that's it. Here I would like just to do a little bit better, hopefully, because it was a order 1. I really want to pass it with the straight line. But this one is by degree 3. Okay, it was our lesson for last class. I like just to do it was exit card for last class. Also, this one I left it for you to do. I'm not sure if you saw it or not, but right now we are gonna do this question together as well. As you see here, I have a bracket. Let me make this one a little bit bigger, maybe. Yeah, it is. Here I have a x by power of 2 for one of the bracket, x by power of 3 another bracket, x and x. If I multiply these ones together, I'm gonna have a 1x by power of 7. 1 is gonna be leading coefficient for this function, and 7 is gonna be a degree for this function. Degree 7, leading coefficient is okay, sign of leading coefficient is positive, then I didn't need to put positive 1 because the degree is odd, opposite direction. Leading coefficient is positive, is going to be finished here. Opposite direction is going to be q3 to q1. How about roots? I have a root 1 in order 2. I have a root negative 1, order 3, root 2, and root negative 2. Y-intercept is gonna be, if I plug x0, I plugged x0 and it was negative 4. 1 is order 2, negative 1 is order 3, rest they are in order 1 that I'm sketching straightforward. Hope makes sense. Okay, there's another question that I really like to do here. It's a mix and match question that you have to find the graph that is matched with the equation that you have. Here I'm starting with part A, shape A. I'm gonna do both ways. First, I'm gonna go over equation, find out the formula, and opposite way. Here, I can see that for A, I have a 2x and x by power of 2. Means the leading coefficient and biggest exponent is gonna be 2x3. 2x3 degree odd, opposite direction, and leading coefficient is positive, is gonna go to the top at the end. Let's see. First shape, both hands are same direction, degree even. This one can be a candidate. I'm just now choosing based on a degree. Here, shape 3, both hands are same direction. And as you see here and here, these two also, they are in same direction, they are even degree, and also this one. For this one, I have a, let's see, I have a degree 3. Degree 3 with the x-intercept, x is equal by 1, x is equal by 0 in order 1, and x is equal by 1 in order 2. Then I need to have a bouncing point at 1 and a normal x-intercept or normal or like a passing at 0. When I'm checking between number 2 and V and like a number 7 here, number 7 doesn't have any 0. Then right away this one's going out. Between these two, look there, I have a x 0 for normal and x equal by 1 bouncing point. Between these two, as you see, this one's a x equal by 1 bouncing point and x equal by a. Then I'm gonna choose this one for a. Good. Now I like just to do in opposite way. Opposite way means that I like to I like to do write it down equation for a graph to see that which graph is matching. I'm starting with the shape 1. Shape 1, both hands are doing same direction. Then I'm expecting an even degree function. And in a right side is going positive, then I'm expecting a positive leading coefficient. Let's see. I have here x equal by 1 and x equal by negative 2. Look like I have a x minus 1 but is not a normal. As you see is passing with the inflection. Then this one has a exponent 3. Also I have a x minus 2 here, x equal by minus 2. That's gonna make x positive 2 for me. Because leading coefficient, as we talked about, that is positive, I'm gonna keep it as it. It can be have any number here, positive, but it has to be positive. Now I'm gonna check to see that which one is matched with whatever that I have here. Part B, oh, okay, is not degree 2, degree 2. Okay, this one is not matching. Okay, I can see part D. G of x is exactly same things, x minus 1 by power of 3 and x plus 2. Then I'm gonna choose D for this one. It is two ways that you can do this question. First, look at the equation, try to find the graph, or look at the graph, write it down the equation and try to make a match. For like this one, I will try to find the I'm gonna go over equation to see that which one is matched with this one. Here, let me go by I choose the A and D, then I'm gonna go for part B. Let's go with equation. It is a negative leading coefficient, x2, x2. I'm expecting degree 4, means that same direction, opening down. Okay, and I'm expecting having a one root at 1, order 2, one root at negative 2, order 2. Okay, shape 1, we already choose this one is not this one. It's a degree odd, opposite direction. This one is a degree even, same direction, and the negative is good. But look at the x-intercept. This one maybe is negative 1 and this one is 0. This 0 has a power of 3. This one is a normal. Is not qualified this equation. Here I'm looking for 1 x equal by 1 bouncing point and x equal by negative 2 bouncing point. Okay, 1 and negative 2, both of them bouncing point. Same things, 1 and negative 2, both of them bouncing point. But when I'm checking, it's a negative leading coefficient. As it is a negative leading coefficient, it has to be open downward. Then I'm gonna choose this one for part B. Now I'm gonna go for part C. C is talking about the x by power of 3, x plus 1. X plus 1 means that x equal by negative 1 as a normal, and x by power of 3 is gonna be at 0. I'm gonna have a inflection. In overall, this equation is a negative x4. I'm gonna choose this one. Look there, 0, because we talked about it. I'm gonna choose it so fast. It's a 0 inflection, and negative 1 is a normal root, and as you see, it's opening downward. Then I'm gonna choose C for this one. Let's write it down, an equation for this one. I have 3 more graph left that I'm gonna write it down, an equation for them. Here I like just to have a x by power of 2, because here as you see x equal by 0 and the bouncing point, then it takes in x by power of 2. and x minus 1 as a normal one, and it has to have a positive leading coefficient. When I'm checking the equation left on the top, A, B, C, look like that. Look like that I have a no equation matching with this one. And as you read the question, there are more more graphs than equation. Then here it's enough for us if we write it down just the equation. I'm going for the next one, this one. I like just to write it down. Y is equal by x plus 2 by power of 2 because the bouncing point here, and x minus 1 by power of 2. It has to has a positive leading coefficient because it's opening up. I choose A, B, C, and I choose D. Look like that I do not have any equation for this one, but we wrote it down the equation. I'm going to the last one. Let's see if I can write it down an equation for this. Here I'm gonna have a y equal by, it's x equal by negative 1, then it's gonna be x plus 1. It's gonna be a bouncing point, then it's a power of 2, and also I have a x minus 2 by power of 3 because it's a inflection point. Here, because it's ending up at negative side in the right side, I know that the leading coefficient has to be negative. Then I'm checking the answer that is matched with that one. E, x plus 1 by power of 2, x minus 2 by power of 3, and there is a negative 2. We just find out it has to be negative. Okay, negative 2 is fine. We do not have enough information to know what is that number. Is it negative 2, negative 1, or any other number? I'm gonna do another question that is working with that one and giving us more information that we can write it down the actual equation. Here is another question we did already, but I like just to do this one as example, and I'm giving you a time to do it. Here I'm just writing I'm just giving a coordinate for this one. Assume that it is negative 2 and 4. Try to do this question. Try to write it down equation for this graph. We did couple of them. Right now is your term, and this equation has a one more step more than whatever that we did before. Let's start to do. Giving you 30 seconds. You go and start, then I will go and do it. Okay, I'm gonna start. First of all, this graph has a like an extra point that's gonna help me to calculate A or leading coefficient. In that case, I'm gonna just put A here. The first root that I have is negative 3. Then x plus 3 is gonna be my first bracket. This one's a normal x-intercept. There is no bouncing point or curving point. Then I'm gonna leave it as it is. Next intercept is gonna be x. X equal by 0, but this one, as you see, is an inflection point. Then this one has a exponent 3. And finally, I have another x-intercept at 4, x minus 4, but this one has exponent 2. Good? Okay, I like to write it down in a better format, and also I like to calculate a actual value. I know that a has to be a negative leading coefficient, but do you remember the previous question that we did? We just recognized it's a negative leading coefficient, but the actual one was negative 2. Here we want to calculate the actual value for leading coefficient. Let's see, I have a negative 2 and 4. Um, I have to put a number. I do not need to write it down. Then 4 is gonna be a negative 2 plus 3 by power of nothing. Negative 2 by power of 3. And finally, negative 2 minus 4. I know y again by power of 2. If I calculate this one, a value is gonna be what? 4 over this bracket is 1, this bracket is negative 8, and this bracket is gonna be negative 6 by power of 2, 36. 36 times negative 8 look like that is gonna be a is gonna be negative 1 over 72. Let me make sure that if I didn't make any mistake, negative 8, no, look like. Okay, I'm gonna write it down, the equation, in a proper way. F of x, the things that sometimes the students are forgetting to do. After calculating everything, they are leaving like the last step to write it down, the actual answer. Okay, negative 1 over 72 look like that. I again have a difficulty for this one. First I'm gonna write it down, x by power of 3, then x plus 3, and x minus 4 by power of 2. It's gonna be the way that I would like to write it down, my final answer. Instead of that one, like you can write it down as a coefficient, or you can write it down as a x by power of 3 over, let me see if I can do it in a better, no way. Okay. Otherwise, I have to close and open the app maybe again. Is It's very interesting that they have a like a glitch just in this class. I'm using this app for another one, but oh, okay, maybe it is the reason. Then I calculated A, and then I wrote it down, the actual answer there. On a previous question, we were just writing the roughly equation, but here if you have just one extra point, one extra point than your x-intercept, you can write it down the actual function for your graph. Okay, I'm gonna start with the mapping notation. So many of you learn mapping notation at grade 11. And on grade 11, you learn about that how you can transfer a parent function to its family with the stretch, with the um, stretch or compress vertically, horizontally, or shifting to the right, left, or moving to the up or down. Now we want to do same things here for the for the cubic function. Here there is example because I know that you learned that on grade 10, sorry 11. Then I'm gonna start with the formula that we have. You saw it before. If not, okay, it's here. The mapping notation for this graph is every x and y from the parent function is moving to the x over k plus d. K is the coefficient for x, and ay plus c. Just make sure that you are factoring the inside of your bracket for x. X has to be alone without any coefficient in a bracket with d. If there is any coefficient for x, you have to factor it at the first point. Like here, I have example here. As you see, this function is look like by this one, but 1 over 3 is a number multiplying by x, but is not factored. Then I would like to write it down this equation again. I need a more space. One over 3. And if I factor it, it's gonna be x plus 3, if I'm not wrong, yes? Uh, this bracket is closed. Another one is closed. Wow, no. I cannot continue with the app that way because it's not just the following, it's just the okay folks, I like just to close and open the app, then hopefully the problem is gonna be solved. I'm so sorry, but let's see. It's better maybe. Look like, I'm not sure. Negative 2, 1 over 3, x plus 3, still not. By power of 3, and finally plus 2. Okay, you start to write it down to describe the transformation. Try to write it down if this function is moving to the right, left, up, down, or is stretching or compressing. And I want to write it down this function one more time from here that I can fit all of them. And you can work on it to see that what is it. It is a reflection. Oh, this function has a reflection as well. power of 3 plus 2. Okay. What did you write it down for it? I like just to start from the left side. Is a reflection to what? A reflection to the x-axis. Yes, because there is a negative here. How about 2? What the 2 is telling me? What the 2 is telling me? Vertical stretch, I'm gonna write it down. Vertical stretch by factor of 2. How about 1 over 3 is saying here? 1 over 3, you know, because it's the x is doing in opposite, then is gonna be horizontal, again stretch by factor of 3. How about this 3 is here? 3 units to right or left? It's a plus 3. I know that. 3 units to left because it's just doing opposite. How about 2? Three units left. Left. How about 2? We said that 2 is gonna be a 2 units up. 2 up. Let's put everything together and try to graph a cubic function. Cubic function in a normal way is gonna be a 1 and 1. 2 is gonna be 8. First, I'm trying just to graph the it's not possible look like to do. Okay. You do it, you start to do, you have a point, try to do the reflection, vertically stretch, horizontally stretch, and you need to the left or right, you start to do it, and I'm gonna catch up. Okay, it's almost x by power of 3. Reflected to the x-axis and vertically stretched by unit of 3 and horizontally stretched by 3 and 3 units to the left and 2 units to the up. Then technically the new center point is gonna be 3 to the left to the top is gonna be this point, then 0 0 is moving to here. It's gonna be a reflection. If it's a 1 and 1, 1 as a vertically stretch is gonna be 1 and 2, and for horizontally stretch 1 is gonna be 3. 3 and 2 means that 3 2, but it's gonna be as a reflection. I forget about the reflection at the first point. No way. I erased by mistake like in my actual graph. Okay. I have another point here, negative 1 and negative 1. Negative 1 and negative 1 again. This one is gonna be 3 units horizontally, 2 units, but it's gonna be on a top. then I'm expecting to see that, to see a graph like that. I just moved 3 units. There is another way doing this question that I really like when you have an actual point. When you have an actual point, it's much more easier when you are doing the graph. X and Y, based on my mapping notation here, I can say that, okay, let's see what are the value here. K is 1 over 3. A is negative 2. D is 3. And C is 2. Then if I use this formula here, I'm gonna have a x over k means that 3x, and plus d. D is 3, then 3, excuse me, d is gonna be negative 3 as a formula, because as you see here, it's a x minus d. Then here I had a x minus negative 3. Then it's gonna be 3x minus 3, and y is gonna be negative 2y plus 2. Now I can find the actual point for graphing. X is negative 2 multiplied by 3 is gonna be negative 6 minus 3, negative 9. Negative 1 multiplied by 3, negative 3 minus 3, negative 6. For 0, negative 3. For 1 is gonna be 0. And for 2 is gonna be 3. For a, y is gonna be negative 2 multiplied by negative 8 is gonna be 16. 16 plus 2 is gonna be 18. Negative 1 multiplied by 2 is gonna be 2 and 2, 4. And 0 makes 2. 1 is gonna make 0. And look like that 8 is gonna be negative 14. Okay. I have a 0 and 0 here. I draw it before. Negative 3 and 2, I have it. Negative 6 and 4, I have it here. Do you see? These 3 points I did based on a whatever that it was, graphing based on this transmission. Negative 9 and 18, okay, is not on this graph, and 3 and negative 14, but we can see that 3 has to be negative 14, am I correct? Negative 16 and 2, yes. Then I had to go more sharp after this point. Then let's fix it. Is gonna be the graph for transformed function. Okay, it is the mapping notation you used to do it until on grade 10, on grade 11 for transferring all of the parent function like absolute value, quadratic, and rational function, and what else you were doing there. Here, as you see, we applied it for cubic function. Here there is a degree for same things, you can do it. I like just to write it down the mapping notation. You can start to do by yourself, and I'm gonna do it here. We are gonna find the points and graph the function. You do it, I'm gonna do it too. X minus 6 and 3y minus 48 is gonna be my transformation. X minus 6 is gonna be negative 8, negative 7, and -6, -5, -4. And for f of x here, 16, 3 multiplied by 16, 48 minus 48. 3 minus 48 is gonna be minus 45, minus 48. 1 is gonna be minus 45, and 16 is gonna be 0. Look like that I need a big number here, like for y value I need a negative number, and I would like just to go -10, -20. Oh, look like that still is not enough. I'm gonna make like that. 40, -50. 1, 2, 3, 4, 5, 6, 7, and 8. -8 and 0. -7 and 45. -6 and 48. And finally, 1, 2, 3, 4. The shape, as you see, is look like a parabola, but it's not a parabola, is skinnier than parabola. As you see, I graphed this one the same way that I was doing for mapping rule on grade 10 and whatever. Here there's example is a little bit can be like a thinking question for this part. The function is reflected in x-axis. Then I know that I have to have a one negative on the top, at the left side. Vertically stretch about the x-axis by a factor of 5/2. And translated 4 units left, 5 units down, write an equation for the transformed function. What do you think? How can I do this question? I'm gonna name it y. Is it reflected to the x-axis? Then one negative is going to the top. Vertically stretch about the x-axis by factor of 5/2. 5/2 is a vertically stretch. Then I'm gonna write it down the equation 2, and it's translated 4 units left, means that all of the x's are moving 4 units to the left. Then all of the x's are taking a 1 plus 4. Then x plus 4 minus 3. And 5 units down. Then finally also I need a 5 units going down. It is my equation, but I need maybe to make a next step doing a little bit simplify. These two are gonna cancel out each other. Then my equation is gonna be y equal by negative 5x this one is gonna be x plus 6 next bracket x plus 6 Next bracket is gonna be x plus 1. Finally, minus 5. You can expand to write it down as an actual polynomial function, or you can leave it like that. Next question. It's asking that what transformation are applied to the function p of x 3 multiplied by 2x minus 4 x plus 2x minus 3 to obtain the next equation. What do you think? I'm gonna write it down p of x in a better format. I know that 2x minus 4, I can factor it. I can factor 2, then multiply by 3 is gonna be 6, x minus 2, x plus 2, and x minus 3. Okay. Compare now this equation with the previous question. I have a x minus 2 here. X minus 2 is good. I have a x plus 2, x minus 1. I have a x minus 3, x plus 3. Look like, first of all, I have a 6. It shows that vertically stretched by factor of 6. Also, as I see, the x's are changing. The value of the x-intercepts are changing. If the value of x-intercepts are changing, means that my function is moving to the right or left. Let's see what's happening here. X minus 2, x minus 2 look like this one doesn't change, but I cannot look at like that. Maybe x plus 2 right now is x minus 2, because the x-intercept can change, can switch, can write it in different order. See what happened between this one, negative 2 plus 3, negative 3, 2, and so on. Find out the value that is giving you to x's. I have a 2, negative 3, and 3 for this one. X is equal by 2, negative 3, this one is not a negative 3, is just negative 2. How about the roots for the other one? The roots for the other one, I'm just writing under, maybe x is equal by 2, 1, and negative 3 for this function. Okay, let's see if I can find out the transformation between these two. The highest like x-intercept is 2 here, 3 here, but here is 2. The highest one was 3, move to 2. 2 move to 1. Negative 2 move to negative 3. Can I say that, okay, for each of them is minus 1, means that all of my function is moving 1 unit to the left? Then the transformation that's happened, I can say vertically stretch by factor of 6. How about the x's? X's, I can say that 1 unit to the left or right, x minus 2, move to x minus 1. That means that 1 unit to the left. And shift 1 unit to left. And that's it for this one. It was a just two transformation here. That's it. Here, I'd like just to go for the next question. There is another two example for the transformation. We like just to make sure that we know it. It can be happen for the odd degree or even degree functions. But the first things that I have to make sure that is factoring the value. Okay, if you can make a note for this one, we did two questions like that before. Right now, you can make a note and later time you can do it by yourself. The thing that you have to do, write it down, the transformation that you have. Okay, look like that horizontally stretched by factor of 2, reflection to the x-axis, 10 units to the right. And also here we like just to write it down, the mapping rule, the points that you have here. Look at the way that I'm doing. If I factor -1, because there's exponent 4, -1 by power of 4 is going to be +1, then I do not need to write it down. I can easily write it down, x minus 6 by power of 4 plus 9. Here, reflect to the x-axis. Then horizontally stretch by factor of 2. By factor of 2. Oh, again, this app is giving me a very hard time. By factor of 2. Then 10 units right. You can write it in a better way, like in a proper way, in the full sentences. But me here, just the app is giving me a hard time to do. And I'm done here. I have just these three transformation. Here, reflect again to the x-axis. Then vertically stretch by factor of 7. Factor of 7. Just a moment, sorry. I like just to close and one more time open it, maybe at least giving me a better service here. Vertical stretch, stretch factor of 7. Then what else do I have? 6 units right, 6 units to right, and finally 9 units to top. Up. The another way that you can write it down is writing as a mapping notation. Here the mapping notation for this function is gonna be x and y What do you think? What's going to be the formula for it? X and y is going to be, I believe so, it's going to be 2x plus 10 for x value. X and y. No, look like that. This app, I'm using it today. It's the last question that I had today. Hopefully that it lets me to do it. Otherwise, I can just tell you what's gonna be the answer for this one. You can do so. X and y is gonna be 2x minus 5. It's gonna be 2x plus 10, comma, and for y I believe so it's just a negative y. It's gonna be the equation for mapping rule for this one. How about here? What can I write it down for the other equation? Here you can see that I can write it down x and y. Okay, is gonna be what? For x, I believe so, x plus 6 is gonna be the confirmation, like a transformation, comma, and y value is gonna be negative 7y plus 9. It is the two transformations that I can do for this equation. Me personally, when I'm doing a sketching or whatever, I prefer to go by mapping notation because it's giving you more accurate point that you can just find the accurate point, connect them together, having a better shape. Folks, I like just to stop here. Next class, I'm gonna go over odd and even function. We had an odd and even function before, but we are gonna talk more about it. Hopefully today's lesson was useful for you. Stay at home, stay safe, and I'm wishing all of you the best. And see you on Friday class. Thank you.